Now question four from a physical scientist question paper 1, physics lana bakhuluma Newton's second law. This is a question, by the way, ngithethe from a November 2017 question paper, and then in the description below uzothola ama links for the other questions akhona kule question paper, right? The question ifundeka ngale ndlela le ithi a tow truck pulls a car along a gravel road. I think circle this. This is a keyword. This is a keyword for the problem, in my opinion. But as the force applied by the engine of the tow truck is 9,000 Newton, and then in the diagram below, bakhombisalo 9,000 Newtons as well. Vele engine kumele apply a force in the forward direction ngoba the tow truck is going forward, right? So that uma iya phambili izokwazi ukuphula le moto from behind, right? The mass of the tow truck is 1,300 kilogram and the mass of the car is 950 kilogram. The vehicles are connected to each other by an elastic, something inelastic. It means irregular, like you want a rubber band, now you pull a so yenzani ya stretch. It means this tow bar by an inelastic tow bar. This inelastic tow bar, it means I stretch, like whether the tow truck na ipula le moto le, the tow bar doesn't stretch, it's inelastic, right? Of negligible mass. See the diagram below, right? Everything about stated up is also being shown on the sketch. And then the statements at Kubega City, the tow truck and the car move at a constant velocity. Important. Constant velocity. So the tow truck and the car are moving at a constant velocity. So keyword, this gravel road is we have friction. We have friction. In a smooth surface asina friction, but on a gravel road komele kube ne friction. Gravel road ayazi njani musa, gravel road vele surface yakhona rough, so we're going to have friction in this case. Constant velocity ngizoyi explainer uma sesiqala ama calculations le, right? 4.1, but define the term frictional force. Frictional force, ngizoshiya look at definition for a frictional force in the description below. But the frictional force is the force that opposes what? Emotion, and then is also parallel to the surface. Like for instance, imoto on a tow truck, because I move on a gravel road, it means naya pambili, the surface is also opposing the motion, meaning surface is to apply a opposing force, and the force is also parallel to the surface. A frictional force in the description below is a sheet definition for a frictional force. Name and state the law that explains why the force exerted by the tow truck on the car is the same as the force exerted by the car on the tow truck. This is dead law, right? Dead law. This statement sounds familiar. When object A exerts a force on object B simultaneously exerts an oppositely directed force of equal magnitude on object bunny A, right? Object A is also the tow truck, and then object B is this one. So in this tow bar, sine tension ngoba I tow truck ipula the car in the forward direction, the car is also pulling the tow truck in the backward direction, ne? in the backward direction as well, but lama forces are equal but at the same time in opposite directions, right? So meaning azocancelana lama forces ala kule tow bar, the tensional forces kule tow bar azocancelana, then basically nothing happens lana, akubi ne-snap, akubi na-next, uyabona? So lana bakhuluma ngo-third law la, ne? In the description below ngizokustatela yona the law as well. Now 4.3, let's get down to business again. Into esizele la, right? Okay, 4.3 but draw a label-free diagram indicating all the forces acting on the tow truck, right? On the tow truck. All the forces acting where? On the tow truck. So now, well, the trick ngama free body diagram is that you have to look at the marks wabo, ne? 95 la ku-free body diagram yakho, it means kwamele ukhombise 5 yama-forces. If it's 3 marks, it means if the diagram yakho yokhombisa 3 yama-forces, right? If uzodraw i-free body diagram yakho ubona ukuthi ngathi ngina 2 yama-forces la, it means this 5 marks angeke uyithola. Study the diagram again ubone ukuthi ama-forces amanye aphuma kuphi, ne? Sizoyi-analyze sonke in this video, right? 4.3 is draw a free body diagram for la. The first obvious force yini? Gravity, ne? The second one yini? Normal force, and then the third one, it's the applied force by the engine, which is 9,000 newtons, right? Which is 9,000 newtons, and then sibane force ebheke in the backward direction, tension esithola la ku tow bar, as well as a frictional force, which is the fifth force ekhona la, right? Now free body diagram, I should draw something engathi bhola nyana la, or you draw a blob, and then let me use a different pen. Sizoba nani ni normal force, and then sibe nani ni weight, and then siba nani ni applied force, F applied or F engine, or 9,000 newtons. Ungambhala naye, I believe ungambhala naye. So sesina 3 ama-forces, 1 mark, 1 mark, 1 mark. Now let's draw amanye ama-vectors for the tension, and then siba ne frictional force. So we have 1, 2, 3, 4, 5. Boom. Siyawathola wonke la ma-marks, ne? These are free marks, free body diagrams, ama-marks wakamahala la, right? Now 4.4, if the coefficient of kinetic friction between the tow truck tires and the road surface is 0.45, calculate the magnitude of the tension in the tow bar for 5 marks. Funa ini the magnitude of the tension in the tow bar. So in this question sizobuyela kuphi? Ngoba bheka basiphi information for what? For the tow truck. So it means ama-equations wethu, or equation yethu for calculating tension, we're going to need any information or data from the tow truck, right? Basiphe nani the coefficient of kinetic friction. Okay, 4.1. Right. It's calculated tension. It's calculated tension la. Right. Ngizobuya back kulo constant velocity. Right. A constant velocity ku-Newton's laws, ne? A constant velocity is we are dealing with Newton's first law. Athi ngenze a note nyana la phezulu. F net is equal to 0. Is equal to 0 for first law, ne? Ngoba first law ukhuluma ngani? Nge-inertia as well as constant velocity or constant speed, and then sibano F net equal to 0. So a constant velocity, just know that whenever there's a constant velocity, so yazi ukuthi okay ngidila no first law la ama calculations wami azo involve uluganje first law, and then in first law F net is equal to 0. Second law sikhuluma ngani nge-acceleration, F net is equal to ma, ne? Ma. Now ku-Newton's laws, uma uzo-calculate tension or any other force, make sure ukuthi uchecka la i-object yakho or in the plane where object yakho izomova khona. Actually, we have two planes in mathematics as well as in physical sciences. As well as in physics, sine horizontal plane sibuye sibe nani ne vertical plane. Now ngoba le tow truck lena imova forward, ne? It means imova kuphi ku horizontal plane. So ama forces ozowasebenzisa for doing ama calculations la, we will check at the horizontal forces, meaning F net wakho for first law and second law uzosebenzisa the horizontal forces la, ne? Uzosebenzisa the horizontal forces or where there is motion. So in this case is sikhuluma nge tow truck, and then komele set up the equation for calculating tension la. Now I tow truck siyabona ukuthi okay this value is given and the object yethu move in this direction. Thina sifuna ubani, sorry, FA applied. F applied is 9. It's given, this one, ne? It's given now 9,000 newtons, and then tensional force is funayo, ne? Friction I can calculate. Remember bangipe ini the coefficient of kinetic friction equal to 0.45, ne? And I know that Fk or frictional force is equal to mu k, which is the coefficient of kinetic friction, times the normal force. So sizodinga normal force for calculating friction, right? So therefore as calculate friction, so mu k is 0.45 times the normal force. The normal force is mass times gravitational acceleration. So the normal force is equal to the weight. The normal force is equal to the weight. So therefore that's why I need to N lana is equal to mg. Ngoba in normal force ne weight iyafana in this scenario. So mass of the tow truck is 1,300 times gravitational acceleration 9.8, 0.45 times 1,300 times 9.8 is equals to 5,733 newtons, right? Newtons. And then we'll have to specify direction. Let's say this direction is backwards and then this one is forward, né? Or we can just say to the left, né? To the left. Now F net is equal to bani 0, and the tow truck is moving horizontally. So now let's F net some calculator using only ama forces in the horizontal direction, right? Let's choose a direction again. Let's say to the right as positive, né? To the right as positive. So therefore it's going to be plus tension plus frictional force subtract, ne? F applied. Why it's negative la, or why it's negative la? It's because FA is pointing to the right, and then tinas to the wait man, FK it's to the right, not left, to the right. This is my right, and then to the right it's positive. So therefore FK or F, let me just say F, free body diagram, it's a F. So F, the frictional force, is to the right, so it's going to be positive. Tension is to the right, so it's going to be positive. FA, applied force, is going to be negative. I face it in the left direction, so it's going to be equal to bani 0. Why is F net equal to 0? Because there's a constant velocity and it means this is Newton's first law. Okay, tensions funa yona, it's plus tension plus F ngiceda ukumcalculator manje. Frictional force, which is 5733 minus FA, it's applied force, it's 9,000 equal to 0. Now T plus, okay, kumele add la, so kumele subtract la. 5,300 minus 9,000 is equal to minus 3,267 equal to 0. Now tension is going to be equal to 3,267 newtons. T is equal to this, ne? And according to free body diagram here too, the tension is to the right, and nale answer iphumayo la iphume njani, positive, ne? But okay, the sign doesn't count, but from the sketch, from the free body diagram siyabona ukuthi T is pointing to the right, so direction yakhona 9, ne? Okay, next question. Bathi 4.4.2, let's calculate the coefficient of kinetic friction between the car tires and the road surface. Okay, now sisiyokhuluma ngemoto ke 4.4.2. as draw a guy a free body diagram for the car. There's no marks for this, but just for the sake of this video, so draw the free body diagram for the car as well. So no tensions, we are no weight, right? So we only have 4 forces acting on the car: the normal force, the weight, the tension in the tow bar, as well as the frictional force. And then check out what is calculated, the coefficient of kinetic friction. This value ifana nale, uyayibona le value ayinama units, it's a coefficient. So the coefficient of kinetic friction between the car tires and the road surface. So lana sifuna a coefficient of kinetic friction, komele sithole ini friction. So ikhumbula le formula le ngibhalele yona la, F frictional force is mu coefficient of kinetic friction times the normal force. So for the car, the normal force I can calculate. The normal force ngakhona kuyicalculator, and then frictional force I can calculate. Tension nginayo, yes, that we calculate in the previous question. I have tension, I can calculate if frictional force, ne? I need a frictional force la to calculate the coefficient of kinetic friction, ne? So check again. F net in any Newton's law calculation, this is how you start my calculations work. F net, if it's second law, F net is equal to MA. Ngoba lana it's F net, la is F net equal to 0 ngoba sine constant velocity, and it means it's first law. So now to the right as positive, I change it. So it's plus F minus T equal to 0. Plus F, I'm looking for a value kabani ga F la. Minus T, calculator, it's 3,267 equal to bani 0. So F is equal to transpose, so equal to 3,267 Newton. In which direction? Right, yes, it's right. It's right according to iloga free body diagram. Right, now saying no bani, saying no F again, man. I have F. I have the value of F, the frictional force, which is also equal to mu K times the normal force. The normal force ngakhona kuyicalculator, because bangipe the mass for the car, and then siyazi ukuthi normal force yethu is equal to m times g, right? F is calculated as 3267, right? So therefore it's 3267 equal to mu k, mass it's 950 times 9,8. So therefore I think ngapha. So therefore mu k uzoba equal to what? 3267. I'm dividing both sides. Now this 950 times 9,8 in total 950 times 9,8. So therefore mu k uzoba equal to 3267 divided by 950 times 9,8. Answer is 0,35. In how many decimal places? So in 3 decimal places, ngati shift fix to 3 decimal places. Ngithanda ukushiya ama-answers wami in 3 decimal places. So answer ithi iphelela la. In 3 decimal places, the coefficient of kinetic friction 9. Ne? Okay. Now something happens again now. An incident during le journey yethu for the tow truck and the car. Something suddenly happens. Suddenly, the tow bar between the car and the tow truck disconnects, and the car comes loose. Check again. Snap. Tow truck is uqhubeke phambili, but what happens to the car? Asibone la. 4.5. Using a relevant law of motion, explain why the car continues moving forward for a short distance. This is a gravel road. Ne? This is a gravel road. So once you snap la, once you gamuka la, tow truck izoya phambili, nale moto still isazomovela phambili. Angisho? Imovela phambili, it's because of inertia. Angisho? First law uthini konje? Uthini first law? An object will continue moving at a constant velocity unless a non-zero force acts on it, right? First law usho njalo. So this car izoqhubeka phambili because there's friction on the surface. Siku gravel road. There's going to be a non-zero force izostoppa le moto from going forward. So that's why le moto move forward only for a short distance. So the net force acting on the car is just this a frictional force. Asibiyela. Bheka 4.2. This is the free body diagram for imoto. Ne? If tow bar yethu yagamuka, it means there's no longer any tension. The only force actayo a frictional force. So izoya phambili kancane izo decelerate or izo slower down because of the frictional force existayo in the between the car tires as well as the surface. Ne? Between the car tires as well as the surface. So that's why izo move here phambili just for a short distance. So I won't write anything for 4.5, but just have a bit of a discussion yana la. Ne? Now, 4.6, maybe I might leave something in the description below, ne? For 4.5, but I won't write anything down for this video. 4.6, calculate the acceleration of the car as it comes to a stop after a short distance. After a short distance. 4.6. This is what's happening, man. 4.6, 9 days ago. we have normal force, weight, and then what? Frictional force. There's no longer any tension, so the only thing I act is frictional force. So lana, the problem now changes from constant velocity to a decelerating scenario. So it means again, F net was over equal to MA. Why? Ngoba sengine deceleration. Whether une deceleration or acceleration, sebenzisa second law, ne? Because F net is the only force active, it's the frictional force, ne? Check out. Let's substitute to look up. The acceleration of the car as it comes to a stop after a short distance. As it comes to a stop after a short distance. So it's no longer it's deceleration, right? So therefore check out. Let's choose to the right as positive again. Ne? Mass 950 times A. We are looking for this value A. F net is equal to the frictional force, and this is calculated in the previous question. Frictional force with 3267. 3267. Ngoba the only F net active la ubani F, and the F pointer to the right, and to the right we chose as positive. So F net is equal to the frictional force plus the frictional force, which is 3267 in the to the right. So now let's calculate the acceleration here to get 550, 950, cancel. So 3267 divided by 950 is equal to 3.44. But we round off to 3 decimal places. Let's just say 3.439 meters per second squared to the right, and we want an answer as a positive. A is equal to this value. So this is a deceleration. Moreover, the car is slowing down. So question here to ipelela lana. Question 4 to pelela lana. So in the description below, Mizushiyama answers for 4.1, 4.2, and the little discussion we had with 4.5. So I hope we enjoy this video. For the rest of the questions for this question paper, please look at the description below. So tolama links for the other questions. So in the meantime, ngizokubona kule video elandelayo. So peace. Thanks for watching. Ungakhohlwa ukulike, ungakhohlwa ukukhomenta, ungakhohlwa ukushare nabangani bakho. Nangabe new to this channel, please consider subscribing. Bye bye.